Now we're going to talk about how wind can affect your landing pattern. On a calm wind day, your landing pattern is going to be pretty square for the most part. Downwind, base, and final are all about the same length. On a high wind landing, your downwind is going to travel a lot farther and a lot faster across the ground than you would on a calm wind condition. This means that your downwind leg of the landing pattern is going to be longer than it would be during normal landing conditions. Your base is also going to be shorter. The reason your base is going to be shorter is because you're going to have to crab the canopy more into the wind in order to get the horizontal distance across the ground. This crabbing into the wind uses up some of the forward speed that you would normally have on a normal calm wind day. Then, once you turn in on final, you are flying directly into the wind, into higher winds, so you're not going to make as much forward movement across the ground. Let's see what that looks like at the Bolivar Airport. We can see the standard, normal, downwind base and final landing pattern that we have drawn out. On a high wind day, you may need to start your downwind a little bit farther back, and you'll also want to turn into the base a little bit earlier. Then, because you're crabbing, you're not going to get as much forward movement on the base leg, and you're going to want to turn in on final just a little bit earlier. Now, we can also see here that the distance we travel on final into the wind on high wind days is a lot shorter than the distance we travel on a normal day. On calm and normal wind days, you want to start getting an idea of how far your canopy glides on final. So if you turn in on final at 200 feet in a calm wind day, you'll want to start making a mental note of how far you travel before you actually land. This will give you a better idea when you start trying to hit a specific target area, how high you need to turn in on final, and how far away you may need to do that turn. Now we're going to talk about how to test the wind and how much forward drive you're going to get on the final approach. The way we test the wind is to try and figure out how much ground we cover flying downwind and then how much ground we cover flying into the wind. Remember, when we do a 360-degree turn, we're going to travel faster downwind than we do when we turn into the wind, and then we're going to pick up speed again when we turn back downwind. So what we want to do, we're going to look straight down between our feet, and we're going to see how far we travel. Right now we're over this X. Traveling downwind, we're going to notice that we probably travel all the way down to be about over where these trees are at. Flying into the wind, we may only get about this far in the same amount of altitude lost. For example, if this is our playground area, we're going to want to test the wind while we hold, making our way to the playground area. So as we fly downwind to our playground area, we're going to turn into the wind. Once we get turned into the wind, then we're going to try and measure how far we travel into the wind. If we don't travel very far downwind, that tells us that the winds are pretty strong and we shouldn't expect to make much forward movement as we turn in on final. The other thing that can happen, if we turn into the wind, and once we get turned into the wind, if we travel a pretty good distance, that tells us that winds are generally pretty calm and we may get some more forward glide when we turn in on final. The other thing that can happen when you turn into the wind, it is possible for you to turn into the wind, and if the winds are strong enough, you can actually get pushed backwards. As you come lower and lower in altitude, the winds tend to decrease a little bit. As you work your way to the playground area, every time you turn into the wind to hold, you're going to want to do one of these tests to see how much forward movement you get. So, how much forward movement do you get when you turn into the wind here? How much forward movement here? And how much forward movement here? This will give you a better idea of how much forward movement you're going to get when you turn in on final during your landing pattern. And now a reminder on some of the student jump limitations. No jumping can go through clouds or close to clouds, and this is an FAA regulation. The USPA does limit student jumps to winds of 14 miles per hour or less. Winds have to be even lower than that on your early jumps. This 14 mile per hour limitation is the most students can jump in, but your early jumps we may scale it back a little bit more. No student jumps are allowed at dusk or night. All student jumps must be completed 30 minutes prior to the official sunset time.